just behind these interpretation panels and big rocks off the car park. If you head, you can just make out there's a small area of rock. It only stands about 3-4 metres tall. So if you glance at it from a distance, it doesn't leap out at you. However, there's a few features which even on a gloomy day like today really stand out, and once you know what you're looking for. So the first one is you can make out, if I stroll up to these, this kind of diagonal stripe effect going up and down. Don't know if you can see this.
Oh yes, I can just see the marks.
Just see the marks there,
yeah.
but it actually goes all the way up. It extends all the way up. What you're looking at here are slicken sides. These are the marks given when one rock slides over another. In this case, we're very near the big east-west Malvern fault that's going along, and we are honestly about 20 metres from it. And this looks like it's a little bit, whether it's part of that or a later feature, you can see that as the two rocks, both of which will have been very hard, this Malvernian rock is very tough, they've scratched each other, giving it this big striped appearance. The other side of that has been, in this case, quarried out.
And so a fault is actually this sliding of one lot of rocks against another.
Exactly, and it's slid, and we can see that they've on the diagonal. In this case, they've gone this way. What that's done is this has all been taken out, but what happened before that is on that fault, that line of weakness, at some point after these have solidified, so after the Precambrian, and in fact after the later fault has formed, in that little gap, hot water full of minerals has pumped through, and it's just trying to get through that line of weakness. This would have happened underground. This isn't overground hot spouting things. And as that water goes through and cools down, the minerals in it crystallise out. In this case, we've got barytes. It's not very big patch of it, but you can see a little patch here and here and down there. In fact, you can see how thin it would have been. Down here, you can see just where it's perched on that surface. And it's where it's exploited, again, it's over there. It's exploited that line of weakness in the same way the veins did with the pegmatite. It's found a line of weakness, the water's flowed through, and you've got these barytes crystals even, a few little patches here where you can see as they've grown slowly. And this is used in drilling mud, although in this case, it's not been quarried for any kind of profit here. It's just that they've taken away the rock, and this is an obvious stable edge, if you like.
So did you say drilling mud?
Yes. So when you need to lubricate a drill deep down in the earth's surface, maybe for getting out oil or anything else, you need something. Barytes is one of the heaviest minerals. I'm not breaking it off. I don't want to damage it, but it's got some serious weight to it. So what they do is they grind it up and add it to the lubricant. Because it's heavy, it'll keep going to the bottom to keep your drill bit lubricated, because otherwise they get very hot when drilling through hot rocks. So this is the main use for this. There are many others. It's barium is this mineral barytes gives us barium.
Okay, you can hear that in the word, can't you?
But you can just see a few crystals. This has not been mined in any kind of formal way. It is just on this surface, which they've left, I'm guessing, because it's the obvious point to end this quarry.